Hi, it's Mrs. Green, and this lesson is compound interest. So compound, if you just think about what compound has a lot of definitions, but one of the definitions is, like if you compound your problems, you're laying problems on top of each other and they're getting bigger and bigger. Or if you compound, I can't think of any other examples right now, but compounding something means you're layering things on top of it or you're making it bigger. And that's the same thing with interest. So if you could write down what you think compound interest might be, your prior knowledge. It doesn't have to be prior knowledge. I would like to see you write down what you know. And if you don't know anything, remember we're going to predict based on other things you know, the meaning of the word compound, and what you already know about simple interest. And the reason I'm having you write down your prior knowledge and think about the topic ahead of time is it engages your brain. One of the things we want to do is not just passively write down the notes, but we want to get your brain involved. All right, so here's a graphic of compound interest, and you can see if I invest the red, which is the principal, it doesn't change because I'm investing the same money every year. So if you look along the bottom, it has years, and up the side it has money. Up the y-axis is the money that you're earning, and you invested this red amount, which is the principal. And then every year they're adding your simple interest as you calculate simple interest, which is what the last lesson was on. That's the yellow bar, and they're adding it. So it's going up because every year you would get the same amount. So let's say your simple interest every year was $50. I can't really tell from, up here, yeah, it's going to be $50 because it's 5%. So they're adding it. So the first year it's 50, the second year it's 100, 150, and so on. So you can kind of see that goes up in a straight line. If you were to connect the dots, it would be a straight line. Not too straight, but that's a straight line going up. But then look at the compound interest curve. It's a nice curve, and it goes up really fast. So if you had the choice between earning simple interest and earning compound interest, think about which one you would choose. So here's the key information I want you to write down in your notes. So I need you to type two parts of your key information. The first one is the definition of compound interest. So we're going to compound. We're not just going to calculate simple interest on the principal anymore. Now we're going to use a compounding formula that's going to let us calculate interest on our interest. So if you type this in, compound interest is interest that is earned on both the principal and any interest that has been earned previously. So that last piece is not what was included in simple interest. With simple interest, we were only calculating interest earned on the principal. Now we're going to compound that by adding the interest every time we calculate interest. We're going to add it in. The principal's going to grow. That's why we get that nice steep curve, and we earn more money. Most of these transactions will be deposits. So this is on the side where you're taking your extra money and you're earning interest on money that somebody else is using, your money that someone else is using. It's not usually used when we borrow money. It's mostly when we're depositing money. Okay, so the second piece of key information is the formula. And you'll see from the example on the next page, I'm not going to do the example yet because I want you to finish writing your key information, but you'll see from the example that there's a formula that you can use to make it simpler. And you'll see there's a pattern. There's a pattern. As you calculate this compound interest year after year, you can see that there's a pattern. And the pattern results in this formula. A being the account balance, equals P times 1 plus rate, or R, to the T power. So that T is an exponent. Time becomes an exponent. The PRT, in our simple interest, we had I equals PRT. The PRT are the same. Principal is P, rate is R, which needs to be in decimal form, and T is time in years. And A is account balance. So we did have that as part of our simple interest. Okay, so now you have all your key information. Let's look at an example problem. And I'm going to write the example problem out two different ways. Okay, so in my example problem, I have I equals PRT for simple interest. I'm just remembering how to do simple interest, and I'm going to compare that with compound interest. So I'm going to use the same parameters. I'm going to use principal of 1,000 rate of 6%, and time in years of 3. And let's remind ourselves what that would look like if we only had simple interest. So here I'm going to have a little chart year after year of simple interest. And I do I equals PRT, so that's going to give me $60 each year. So if I write each year out, you can start to see that it looks the same. And that's where we get our simple interest calculation, where we're multiplying principal times rate times time. And I did it year by year just because we're going to do that with the compound interest. And you can see that I can shortcut that by using the I equals PRT and multiplying it by 3. Because it's the same every year, $60, $60, $60, so I can shortcut that by replacing my year with a 3, and that gives me my original simple interest calculation that we learned before. Let's look at how that would look if we compound it. So now we're going to do compound interest. So in my first year of compound interest, exactly the same thing occurs as it does with simple interest. I earn $60. But if I want to calculate my account balance, I need to add my original principal back, and that's going to give me $1,060. And that's exactly the same thing that would have happened if I had added my 1,000 up here. At the end of my first year with my interest, I have $1,060. Now the change between simple and compound is I'm going to take that $1,060 and that's going to be my new principal. So in my compound interest calculation down here, instead of $1,000, I now have $1,060. Everything else remains the same, 0.06. And we're just going to go year by year, so I'm not putting the 3 in right now. So I want to show how this changes year by year. This would be an excellent time to use a calculator. I used a calculator when I did these problems. And then I'm going to add the principal. But remember, my new principal was $1,060. $1,060. I'm trying to write my zeros so they don't look like sixes. And then if you total the interest and the principal, you get $1,123.60. Now I have to plug that into my compound interest formula to get, well, it's the simple interest formula. I'm just compounding it. My behavior, my calculation is I'm compounding by adding my interest in every time and then changing my principal. So my new principal now would be $1,123.60. Multiply that by everything stays the same. So now my interest is $67.42. So you can see by the third year, I'm earning $7 more than I was earning up here with my simple interest. And my amounts aren't very big. You can imagine if you had a lot of money for a lot of years, the amount just keeps getting bigger faster. So my principal, again, I'm going to add my principal from the second year, which was $1,123.60. I'm changing my principal every time, and my interest is going up every time. So lots of things are going up. And by my third year, I'm earning $1,191.20. Up here, I would have earned $1,180 because I had 3 times 60 for my simple interest. So not a lot more at this point because my numbers aren't really huge, but you would be surprised how fast the compound interest makes you more money. And this is only being compounded annually. There are accounts that compound monthly, or there's also something called continuous compounding, which makes it a lot bigger number. All right, so you might have noticed, I want you to notice that there's a pattern. So I kept adding my principal, I kept adding my interest and increasing my principal. My rate was the same, my year was the same. So you might notice that there's a pattern, which is how we developed that formula. So on my next screen, I'm going to use the formula to calculate the same set of information. Principal of 1,000, rate of 6, and years of 3, and I'm going to fill in that formula from your key information. Fill this formula in and do the math. So I did 1,000 times 1. My principal was 1,000. 1 plus r would be 1 plus 0.06, and that's going to be compounded with an exponent of 3, which is equal to my time in years. So I get the 3 from the time in years. So I had to use a calculator to multiply 1.06 times itself 3 times, and that gave me 1.191016. I wouldn't expect you to have to do that on paper, but you could. And then when we go to practice compound interest, I will suggest that you use a calculator, and you could certainly do that at home. So we get, if we move the decimal 1, 2, 3 times, which is multiplying by 1,000, we get 1,191.02. I rounded because we're talking about money, and you would never have 3 digits on the right-hand side of the decimal for money, because we don't have thousands of a dollar, we have hundreds of a dollar. So that, remarkably, is the same as what I got when I did it manually, year by year. So the formula is a little bit less work. It is something you have to memorize versus if you just logically think what would happen if you're adding the interest. You can derive compound interest without a formula. And I like you to know both ways. So I'm going to ask you to practice both ways with these two situations. The first one is a principal of $800, rate of 5% annually, and 3 years. And then the second one is $700 with a rate of 6.2%, 24 months. So be careful with the months. You need to convert that to years. And then I want you to find the balance in the account, so that using both methods. I want you to use both methods. So first use the method where you write out each year, like I did in this table. Then you can use, I did it twice. That's why there's that other page. Then the second way I want you to do is use the formula, and you should get the same answer both times. That's a nice double check. Check. All right, the end.